4.5 billion years ago, a vast celestial body slammed into the young Earth. The violence of the impact flung a cloud of debris into orbit. Cold and gravity did the rest, forming the Earth's natural satellite, the Moon. But ours isn't the only moon. There are many other moons in our solar system, and some scientists consider them to be worlds in their own right, where life in some form might exist. So a number of missions have spent time aimed at exploring them further. Jupiter, the giant planet, has moons that NASA's 1995 Galileo probe spent 8 years exploring. They include the sulfurous volcanic inferno of Io and Europa, lurking in the coldest part of the system, hidden beneath its frozen crust, an immense liquid ocean. In December 2000, the joint NASA-European Space Agency mission Cassini-Huygens took the first ever high-resolution photos of Jupiter and its moons as it passed towards its main goal, Saturn, its rings and its system. Launched in 1997, it took 7 years for Cassini-Huygens to reach Saturn's orbit on a mission scheduled to last until 2011. The Laboratory for Space Studies and Astrophysical Instrumentation in Paris has been studying Saturn's moons.
Today we have about 56 of these moons discovered, and each one of them is a jewel in the solar system and in the Saturnian system. They're extraordinary, they are active. Saturn and its system is an active system. There are interactions between the moons and the rings, and between the rings, the moons, and the planet. So it's everything an astronomer could imagine, could hope for.
Cassini-Huygens has revealed much about the structure of Saturn's rings, which are made up of millions of lumps of rock and ice orbiting the gaseous planet like an army of mini-moons. It also captured the first images of Phoebe, the most distant of Saturn's satellites. And it revealed the pristine beauty of Enceladus, the ice moon, with its dramatic volcanoes at its south pole. At the Free University of Berlin, another research project examines the craters made by meteorites crashing into Iapetus, another of Saturn's moons, discovered in 1671 by the astronomer Jean-Dominique Cassini. This icy celestial body, 1,500 kilometers in diameter, has a number of unusual topographical features. Almost half of its surface is as dark as coal, while the other half is as bright as snow. Images from the probe taken in 2004 also reveal an icy ridge running almost entirely around its equator. And then there's Titan, Saturn's biggest and most fascinating moon. In January 2005, the European lander Huygens separated from Cassini. It set down as planned and on time. And what it sent back stunned the scientific world.
We discovered that there was a whole new world waiting for us, because we knew something about Titan's atmosphere, but we didn't know much about its surface. And here we come through the Titan atmosphere, we land on the surface, and we find not only hydrocarbons that we thought, but we find lakes, we find dunes, we find mountains, we see clouds, enormous clouds and storms coming through the atmosphere. And so this is a fascinating object. Could life evolve on such an object different than the Earth with a different chemistry? Can we find geological processes that we didn't know of on Earth because they look similar but they're made of different material, and so on?
Huygens lasted barely a few minutes on Titan's hostile surface, but in that time it opened new horizons.
We feel like discoverers, adventurers going out there. And I think that's what the revelations from Cassini-Huygens showed us for Titan. It's that there are other worlds out there to be discovered. There are other objects and we don't know everything about the solar system. We really need to investigate.
Which is why Europe plans to do more exploration at national and international level in the near future. The European Space Agency will, for example, be part of Chandrayaan, the Indian lunar mission. Indeed, the quest to explore the universe's moons, including our own, is far from over.
The first cooperative venture between India and Europe took place in Kourou back in 1981 with the Ariane 3 launch of Apple, India's first geostationary satellite, an experimental telecommunications spacecraft. At the Indian Space Agency Museum in Bangalore, Apple takes pride of place. India then went on to develop a number of telecommunication satellites. The INSAT satellite family, which was also designed for weather forecasting and Earth observation. In total, Ariane in its different versions has launched no fewer than 13 INSAT satellites.
I think we have been having the close cooperation with the ESA and the member countries in many respects right from the beginning of the space program. I would say it is a major achievement as far as the cooperation between ISRO and ESA is concerned.
India has also developed its own launches at its Sriharikota base in the Bay of Bengal, putting it up alongside other space powers. With its lunar mission, India is about to enter a new stage. This is Chandrayaan, a lunar craft that is a real technological and scientific achievement, and the international community has been invited to take part in this important event.
As far as the Chandrayaan mission is concerned, mostly the work is done by the Indian laboratories and the industries. But at the same time, we wanted to make it a truly international mission. Against the announcement of opportunities, we got as big as about 30 proposals. Out of that, 6 of them we have shortlisted, 2 from USA and 4 from Europe. And I'm happy that it's become a truly an international mission, and the global scientific community is going to benefit out of it.
Instruments developed by ESA for Smart 1, launched in 2003, or planned for use on Bepi Colombo, are loaded onto the Chandrayaan probe. This is an opportunity much valued by European scientists.
We have science, technology and cooperation, and also we have a cultural exchange, and it allows us to give additional points of contacts to Indian scientists, and I hope that in future a scientific exchange and a fostering of science will result out of this mission.
There will have to be a follow-up to Chandrayaan, but India has also expressed its interest in other forms of cooperation that go beyond lunar discovery and astronomical missions.
I think in the future we want to be closely working with ESA in many of the areas. The one, of course, is the planetary exploration, whether it is a moon or Mars. We have to have the continuity program. But also I understand the Galileo program is going to come up in Europe. Similarly, we are going to have the Indian regional navigation system as far as India is concerned. If we can have these systems interoperable, that is going to provide a lot of service globally. Again, there are a lot of technical areas where the strength of Europe and India can be put together, and we can provide appropriate solutions in the space explorations in the future.
This large antenna was designed by the India Space Agency and specially installed some 30 kilometers outside Bangalore to monitor the Chandrayaan mission.
It has international character in sense saying that all specifications which we have put for this deep space antenna, the IDSN is what we call Indian Deep Space Network Antenna, meets the international standards. That means it can be used for cross-support and interoperability. Both of them can be offered, not only for Indian missions. If ESA wants or NASA wants, we are there in this part of the hemisphere, closer to equator. It enjoys a lot of advantages technically, and that's one proud thing for us to tell that, yes, we have an Indian antenna available for the international community.
It forms part of India's deep space network and is a good illustration of India's desire to play a role in the conquest of space and to offer its services to other countries.